We are finally on the last section that we are going to cover, so you can go ahead and cheer now. The last thing that we are going to discuss in the course is graphing quadratic equations. There's two ways to do this, so I'm going to present this as two different presentations. The first one that I'm going to present is using tables. It is a little more tedious, but in terms of remembering all the different steps, it is easier. So in order to graph quadratic equations using tables, a couple things that we will need to know before we begin this is understand how to find points by plugging in values for x, know how to plot points in the rectangular coordinate system, and know how to identify x and y intercepts. Recall that when we were working with linear equations, we had three key features when graphing lines. We had an x-intercept, where the graph crossed the x-axis. We had a y-intercept, where the graph crossed the y-axis. And we had a slope. I'm not going to care so much about the formal definition for slope here. Just remember that slope determined how steep the line was and whether it was an increasing or decreasing line. Basically, did it go up from left to right or did it go down from left to right? We're going to have some of the same features here, and we will also include some new concepts. When graphing quadratic equations, we still have some of the basic concepts. For instance, we still have x-intercept. The x-intercept is still where the graph crosses the x-axis. And recall that when finding x-intercepts, or when identifying the x-intercept, what we are looking for is when y is equal to 0. For many of the equations we're going to look at, we have three possibilities. You can either have 1, 2, or no x-intercepts. For y-intercept, we still have the same definition, where the graph crosses the y-axis. And remember that to find the y-intercept, we want to plug in 0 for the other variable. Here, it will be plugged in for x. Every quadratic equation will have a y-intercept. With lines, we talked about slope and whether it was increasing or decreasing. We have a similar concept when we talk about quadratics. We have, instead of a slope, we have a direction. When we graph a quadratic, it's called a parabola. And a parabola looks kind of like an umbrella. And so we can either open our parabola up or down. The newest concept that we did not see or don't have anything related to it when we talk about linear equations is the vertex. The vertex is the highest or lowest point on the graph. It is your peak or your valley. We'll talk about how to find this one in a few minutes. So before we begin talking about quadratic equations and looking at some of the examples we're going to look at, I just want to start by identifying how each one of these is going to play into it. Mostly, I want to look at direction and vertex. Alright, the first thing that I want to point out that's new about quadratic equations is direction. These two here are two of the most basic quadratic equations that you can come up with. So the first thing that I want to do is create a table of values so that we can kind of see what we're going to be looking at when we graph these things. So let's start with y equals x squared. If I create a table of values, let's say x is -2, -1, 0, 1, and 2. I want to square each one of these numbers. Remember that you do want to square the whole thing, so -2 squared is equal to +4, since it's -2 times -2. -1 squared is equal to +1, since it's -1 times -1. 0 squared is 0. 1 squared is 1. And 2 squared is 4. We have our values now. Let's go ahead and look at the second equation and come up with a table of values for this one. Now, remember that you do need to be very careful here with your negative because it is not inside parentheses. So when we create our table of values, let's use the same ones again. We get minus negative 2 squared. We have negative 2 squared is 4, and now I keep my minus sign. So we get negative 4. For negative 1, we have minus negative 1 squared. Similarly, what we have is negative 1 squared is 1. Keep that outside negative, and we get negative 1. Minus 0 squared will be 0. Minus 1 squared. Since 1 squared is 1, we keep our minus sign with it, and we get negative 1. And similarly with minus 2 squared, we're going to end up with negative 4. Now that we have our table of values, let's go ahead and graph this. To graph the first one, let's begin by plotting points. So negative 2, 4 means I want to go left 2, up 4. We end up right here. Negative 1, 1. We go left 1 and up 1. 0, 0 will be at the origin. 1, 1 will be 1 to the right and 1 up. And 2, 4 will be 2 to the right and 4 up. Now you have to be careful when graphing these, because when you graph them, they are not going to be V's. It's kind of going to be a U-shaped V, a curvy V. So if we draw it, we end up with something hopefully better than this. It'll have to do. If we graph the second one we have negative 2, negative 4, which is going to be down in the third quadrant, negative 1, negative 1, 0, 0, 1, negative 1, and 2, negative 4. Again, when we graph this, we should have something that looks like a curvy V. Make sure that when you graph this, that your parabola, which is what this is called, never starts turning into an actual U. Your lines will never be parallel. Also, make sure that it's not a complete V shape. It has to be somewhere in the middle. So let's see if we can figure out what determines the direction. So if you recall, when we talked about slope and linear equations, remember that our equation y equals mx plus b was our slope-intercept form. If m was positive or greater than 0, it was an increasing line. And if m was less than 0, if it was negative, it was decreasing. Similarly, when we talk about parabolas, if you have that your leading term, the number in front of the x squared, is positive, your parabola is always going to open up. Whereas if your leading term is negative, your parabola will always open down. The second concept that we have, which we'll have to work on in the next couple slides, is notice that our blue graph has a vertex at 0, 0. It's the lowest point on the graph. The other thing that we have is on each side of the vertex, notice that your y values are the same. When we talk about creating tables for this is going to be what we want to look for. And so the next thing that we want to look at is how do we find a vertex if it's not one of our most basic equations. As mentioned earlier, the vertex is the highest or lowest point on your graph. We have a formula for vertex, and just to note, this is not a new formula. This actually comes from your quadratic formula. If you get rid of the plus or minus, square root, blah, 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 you have your formula for the x-coordinate of the vertex. I only mention this because on the final exam, hint, 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 you will be given the quadratic formula. So there's no reason that you can't go look at that problem and just take everything except the plus or minus, the square root of blah, blah, blah. This only gives you the x coordinate though. So how do we find the y coordinate if it's a point? To find the y coordinate, you want to plug the result into the equation. In order to graph using tables, what we want to do is first find the x-coordinate of the vertex. We're going to evaluate, we're going to solve for y by plugging it into the equation and simplifying. From there, what we want to do is we want to find numbers on either side. So for instance, we can add and subtract 1 from the x-coordinate, placing these values above and below the previous number. We can evaluate each one of them by plugging it into the equation. We repeat the process, add and subtract 2 from the x-coordinate of the vertex, placing above and below the previous numbers, and evaluate each by plugging into the equation. Repeat the pattern until you have all key points, including the x and y intercepts. So let's go ahead and look at an example of graphing using tables. Let's start with an example, y equals x squared plus 4x plus 3. To start off with, I want my x-coordinate of the vertex. I want to plug in my values for b and a into the equation, negative b over 2a. If we do this, we get minus 4 over 2 times 1. 2 times 1 is 2, and if you divide negative 4 by 2, you get negative 2. So that's going to be kind of the center of our table. I'm going to go ahead and go up negative 1, or negative 3, negative 1. I'm also going to go up to negative 4 and 0, only because I do need to have my y-coordinate, which is where x equals 0. So now, if we go ahead and plug in these values, let's see what we end up with. If we plug in negative 4, I get y equals negative 4 squared plus 4 times negative 4 plus 3. Using order of operations and or your calculator, you should be able to simplify that down to 3. If we plug in negative 3, we get negative 3 squared plus 4 times negative 3 plus 3. And again, if you plug this into your calculator or use order of operations, you should get 0. Repeat the process for negative 2. If you plug in negative 2, you should end up with negative 1. If we plug in negative 1, we should get 0. And if I plug in 0, I should get 3. And so here is our table of values. If you notice here, we have our vertex, at negative 2, negative 1. If you notice on either side of the vertex, again, we have the same y values. So for instance, if we go 1 away from the vertex, we get 0s. 2 away from the vertex, we end up with the 3s. Also, one of the nice things that we have is we have our x-intercepts. That is when y is equal to 0. We have our y-intercept, which is when x is equal to 0. So we have all of the key things that we need in order to graph this parabola. So let's go ahead and plot our points. I have negative 4, 3. I'm going to go 4 to the left and 3 up. I have negative 3, 0, which is 3 to the left. Don't go up or down. We have negative 2, negative 1. 2 to the left and 1 down. Negative 1, 0. And 0, 3. We can go ahead and connect our points. And when we do that, we should get something that looks roughly like this. This is everything that you need. And of course, on the exam for the final, you do want to go ahead and label each one of your key points, which is going to be the y-intercept, both x-intercepts, if you have to, and the vertex. The negative 4, 3, this is the only one that isn't a relevant point, but one of the reasons I suggest having that 5th point there is just to kind of balance out your quadratic, to balance out the parabola, so that you can see that it is symmetric on both sides. I'm going to bounce around a little between the examples. The next example that I want to look at from your notes is example F. And example F is y equals x squared plus 4x plus 4. So, if we wanted to find the x-coordinate of the vertex, we get x equals negative b over 2a, which is going to be negative 4 over 2 times 1, giving us negative 4 divided by 2 equals negative 2. If we go ahead and create our table, I'm going to have negative 2 at my center. Above that, I want to go negative 3 and negative 4. Below it, I want to go negative 1 and 0. So let's go ahead and start plugging in. If I plug in negative 4, I get negative 4 squared plus 4 times negative 4 plus 4. And using either order of operations or a calculator, you should get y is equal to 4. If we plug in -3 squared plus 4 times -3 plus 4, this is going to equal +1. If we plug in -2 squared plus 4 times -2 plus 4 equals 0. Let's plug in -1. -1 squared plus 4 times -1 plus 4 equals 1. And if we plug in 0, 0 squared plus 4 times 0 plus 4 equals 4. So let's go ahead and see what we have here. We do have an x-intercept, we have our y-intercept, we have our vertex, and so we do have all the key points that we need in order to graph this. So let's go ahead and graph it. If we start by plotting our points, we have -4, 4 is going to be 4 to the left and 4 up. -3, 1 is 3 to the left and 1 up. -2, 0 is 2 to the left, do not go up or down. -1, 1 is 1 to the left and 1 up. And 0, 4 is on the y-axis going straight up 4. We can go ahead and graph. And it should look roughly like that. I want to label my key points, and this one only has 2 key points because here my vertex and my x-intercept are the same thing. If your vertex is on the x-axis, then you will only have one x-intercept. Similarly, if you have only one x-intercept, it's because your vertex is on the x-axis. This is an example of an equation that has just one x-intercept. If you were to solve the equation by plugging in 0 for y, you would also have only one solution. You would have a repeated solution. All right, let's look at one last example in terms of using tables. Now, one thing I do need to note before we do that is that in the next presentation, I'm going to show you how to graph these things without using tables, meaning the procedure for finding x-intercepts, the procedure for finding y-intercepts, the procedure for finding the vertex. And one of the issues that you have here is if we only have the y-intercept and a vertex on the x-axis, then we don't have enough information in order to get our shape. So when you have a special case like this one, then what you would need to do is you would have to resort to tables in order to find other points. So tables can be very helpful, just like we saw when we graphed horizontal lines and vertical lines and lines through the origin. Every now and then we did have to just pick values and plug them in. With quadratics, same thing. There are certain examples where you will have to find values and plug them in depending on what you get when you find all of the key points. For our final example using tables, let's look at y equals -x squared plus 4x minus 1. So to start off with, again, I want to find the x-coordinate of my vertex. The x-coordinate of my vertex is going to be -4, negative b, over 2 times -1, which is 2 times -1. If we simplify this, I get negative 4 divided by negative 2, which is equal to positive 2. So for my table, I'm going to let positive 2 be in the middle. I'm going to subtract 1 and add 1. I'm going to subtract 2 and add 2 so that we have this. Nice thing, we do have our x equals 0 in the table, so that's always nice. And so now we want to go ahead and plug in these values. Make sure that you are very careful on this one in terms of that minus in front of the x squared. Remember that we talked about direction. This should open down. So let's start plugging in values and see what we get. If I plug in 0, I get minus 0 squared plus 4 times 0 minus 1 equals negative 1. If we plug in 1, we get minus 1 squared plus 4 times 1 minus 1 equals 2. If I plug in 2, I get minus 2 squared plus 4 times 2 minus 1 equals 3. If we plug in 3, we get minus 3 squared plus 4 times 3 minus 1 equals 2. If we plug in 4, we get minus 4 squared plus 4 times 4 minus 1 equals negative 1. Now, one of the things you may be noticing here is that we don't have x-intercepts. We do not have a 0 in our column, in our y column, anywhere here. But here's the thing. You can have x-intercepts. They may not necessarily be nice numbers. If you notice the original problem, this does not factor. So we do have x-intercepts, but they're not nice. And for me personally, if they're not nice, there's no point in finding them, just because are you going to be able to graph it exactly? The whole point is graphing. And if you can't graph it precisely, then there's really no point in finding it. But note that here, when I look at this, I am going from positive to negative. I do know that I have an x-intercept somewhere between 3 and 4. Same thing up here. I'm going from a negative to a positive. So I do know that I have an x-intercept somewhere between 0 and 1. So let's go ahead and graph this now. If we graph this, I have 0, negative 1. I have 1, 2, 2, 3, 3, 2, and 4, negative 1. And so when I plot this, and when I connect the dots, we should end up with something that looks like this. As I said, on this one, we do have a y-intercept. We'll always have a y-intercept. Your y-intercept will always be a nice number. We have a vertex. And for this example, as I said, I'm not going to worry about calculating the x-intercepts because they're going to involve square roots. And can you graph a square root of 5? Yes. Is it going to be precise? No. So those are not going to be good points. This is another example where we found two things out of our list, out of our vertex, y-intercept, and x-intercepts. We found two nice points. So again, if you are going to use the second method that I'm going to present in the next presentation, this is another example where you would have to break down and use a table and start plugging in values on your own. So knowing how to do this using tables is always beneficial, because every now and then you're going to have to do it anyway.